let's get into the big topic of open source, something that we actually say at Red Hat.
This is so awesome.
We are an open culture that believes in the importance of
What is that process that a developer, or let's say,
as the Kubernetes ecosystem really boomed?
Hello, good morning, good afternoon, good evening, wherever you are in the world. This is the Ask an OpenShift Expert live stream. We're back 2 weeks in a row. We did it.
And both of us here 2 weeks in a row, no less.
Yes, we did it.
Yeah, sadly, the streak will end next week.
All good, man, all good. So how's things going?
Good. So I was lamenting with some of my long-term friends, former coworkers, folks who have been doing like tech marketing for a long time, like I have. Of like, I remember when the summer was kind of the quiet season, because it's after the spring set of conferences, it's before the fall set of conferences, and this year it's been very busy, and
Yeah.
there's a number of things that are coming up in the fall, mid fall timeframe that are happening, and so like I've been having to, like part of my job is to prepare for those things and orchestrate how everything comes together and all that other stuff, and that's not to mention in early next year. So January is when our much beloved Red Hat One event happens. We're already in the process of starting the labs for that one and everything. So for your Red Hatters that are listening, there's going to be a plethora of OpenShift things there covering all different type of topics that you'll be able to get hands-on with. And it's just, I don't know, I miss the summer doldrums.
Yeah. Well, especially now, like with how OpenShift virtualization has gone completely off the freaking hanger, right? Where, I mean, just now it's super popular and all over the place. So now you've got like the KubeCons and the summits and are you involved with the Connects, like the smaller summits, or is it mainly just kind of like high level upstream?
Yes, but no. Like I'm aware of them through like the labs and the stuff that'll be there, but I'm not a part of any of the execution of them.
Okay.
I don't even know if we're having one in Raleigh this year. If we have one in Raleigh, I might show up. But yeah, other than that, yeah, I don't have too much involvement with them.
Yeah, that's how it was. Like, if it was in San Antonio, I did my best to go to most San Antonio events, or even if it was like near the area, I would try and go. But yeah, anything like Houston or Dallas, where it's like, is it worth sitting in traffic for hours? Like, no, I don't think so.
I mean, I do enjoy the Connect events. I would love to go to more of them, but on the other hand, like I just can't travel like I used to. So
yeah,
it's hard to get away and get to them. But anyways, enough of me whining about being gainfully employed and having plenty of things to do. I know. So I know we'll get to the top of mind things that we got in a minute. So today's stream is me fulfilling the promise that I made back at Summit. Speaking of Summit Connects, where I presented 2 sessions while I was there. One was the storage deep dive that we did a month and a half ago. It's been a minute. And then the second one was this networking deep dive. So at the time, they were put in context of OpenShift virtualization, but reality is networking is networking, right? And so most of these things, while they have a virtualization skew, they also apply to any workload that's running inside of OpenShift. I will point out that it is bare metal OpenShift centric because virtual OpenShift, we generally don't have to care about like host level networking, right? It's handed to us by the underlying hypervisor, but we'll cover all those things. Y'all know the drill. Like, let's ask questions. Feel free to poke things in there. I figured out, and by figured out, I mean I did a quick internet search of like how to freehand draw things using the Chrome canvas. So I actually have a few things that aren't in a slide that I want to kind of draw to help illustrate some concepts that I hope will make sense to folks. But yeah, as always, don't hesitate to ask questions and all that other stuff. But before we get into it, Jonny, top of mind stuff. I know you had a few things. I did not. I've been on calls literally since 8:30 this morning, so I did not have time to research top of mind topics.
No, all good, man. All good. Yeah. So like basically it's just a bunch of blogs that I've been I've come across that I thought would be interesting to people, especially with the topic at hand today. And then some of the stuff that we talked about last week with, the EVPN feature with OpenShift 422. So Mark Curry, who's the networking guru on the OpenShift side, created a blog, and it really does a good job of breaking down like what the EVPN feature does. And it's like, hey, if you're trying to connect to these external networks through a BGP, he does a really good job of describing it and explaining it. And then he actually shows some pictures to help kind of like walk through the connections. Another one is there's a guy that you and I both know. I'm sure probably more than you and I both know, named Tom Hall. I actually met this dude. It was kind of crazy. I was on a flight coming back from Summit a couple years ago, and he's in the seat next to me. And we just started talking. He's from, I lived in San Antonio. He's from the next town over. And he told me about this place in San Antonio that had like these great breakfast tacos. And so if you know me, I'm a foodie, right? Which is a nice way of saying that I'm a plus size red hatter. And dude, he didn't disappoint. He was spot on about these tacos. These were probably some of the best tacos I've ever had. So every time I talk to him, I always bring up Mary's Tacos. But anyways, he wrote this blog about having some vCN like storage, capability. So if you don't know what vCN is, in a nutshell, it's basically like hyperconverged storage, right? It's storage that's inside of your cluster that you can allocate, utilizing local disks within your VMware nodes. And so he kind of went through and outlined some of the different technologies that are out there that you can take advantage of if you were so inclined.
Yeah. I'll point out. So HCI is sometimes a loaded term depending on who within the vendors you're talking to. So for example, for reasons, we don't consider OpenShift with ODF to be HCI. And those reasons are, depending on my mood at the time, they're kind of arbitrary, right? And it's things like, well, with HCI, you expect it to be like this fully vertically integrated, stack of things with everything inside of one dashboard UI, et cetera. Well, ODF has a dynamic console plugin into OpenShift, so it kind of meets that criteria. And so sometimes it definitely feels arbitrary and just like we're drawing a line in the sand for no reason other than to have a line in the sand. From my perspective, industry-wise, when I talk with folks, everybody considers an architecture where you have compute and storage in the same box to be HCI. I'll point out that many of the vendors who claim to be HCI also include networking inside of there, which, okay, if we want to go down that path, right? Hey, we've got OV and Kubernetes, and now as we were just talking, EVPN and all these other things. So HCI also, can potentially include networking inside of there. And again, so long story short, this is my long-winded way of saying like HCI is sometimes a loaded term, but ultimately, if you care about having compute and storage in the same box, then that's typically the term you're looking for. And there's a lot of really great options out there. It's not just ODF.
Yeah. As a product though, didn't we? It was around Gluster. That's when we did like the OC, like when it was OpenShift container storage. That's when we would call it hyperconverged, right? When it was all built into like a SKU. I don't know if it was a SKU, but like you could actually deploy it all as one. Yeah, I might be thinking of something else.
We used to have a product called Red Hat Hyperconverged Infrastructure, or RHI, RHHI. There was two flavors. One was RHI V and one was RHI something else. One was Red Hat Virtualization Rev based. The other one was, I think, OpenStack based. And the Rev based one, RHHIV, that was the one that used Gluster for the storage on the underneath. OCS, OpenShift Container Storage, which is the old name for what is now OpenShift Data Foundation. I don't know if that was, I don't know if an OpenShift 4, if that was always Ceph based or if it might have started out being Gluster based. I thought
Don't get me lying.
Based. Yeah.
Yeah, I thought it was Gluster, but I could just be making stuff up. Like me and product names, we don't get along very well. So.
Yeah, I'm terrible at naming things. Just ask my children. So, yeah. Anyways, to your point, yeah. We used to have a product that we called hyperconverged infrastructure. We no longer have that product.
That's right. And when you said virtualization, I remembered it was Rev. That's the one I think I was thinking of and that was with Gluster. Yeah.
Yeah.
Yep. But yeah, so a couple weeks ago we had Natali Vento on, and he was talking about agentic CI/CD. So he came on the stream before the blog had actually released, and so this time we actually have the blog, and now it's released, and so just wanted to share that out. But it goes back through what he was demonstrating while he was on the stream, where you have CI/CD, you have OpenShift pipelines, you have these guardrails within the pipeline to help. Hey, I want to use the agent to try and figure out what's going on without actually doing anything. So it was a cool demo. It'll be a cool feature when it gets in the product. And yeah, just wanted to share that. And then finally, this is also from your coworker, AC, and I can never say this dude's name, but he was on the stream. He did service mesh, and it's coolest. Do you remember? It's I can't remember, something coolest, but they did a blog and actually like a workshop at Summit on managing OpenShift virtualization in service mesh, and so that is here. And so yeah, just check it out. It's a really good blog. If you're within Red Hat, there's a catalog item in the demo platform where you can actually go through and spin up an environment and go through the entire Summit workshop, which I thought was awesome. I went through that today. I was looking at it this morning. It's really well done. So if you're at Red Hat and you can get into the demo platform, it's worth your time, I think.
Yeah.
So
if you're not at Red Hat, reach out to your account team and see if they can provision an instance of it and give you access to it.
Indeed, yeah.
They're short-lived. They only live for usually a day or so. So just keep that in mind.
Yeah, but it comes with the environments already provisioned, so it's literally you just go right through the lab, and yeah, I thought it was really well done. AC does a good job.
Yeah. He and Ryan, Alan and Ryan on my team are the two who manage all of the virtualization labs. So if you've ever done an OpenShift virtualization roadshow or the operations, day 2 operations, or there's also a modernization with virtualization 1, like that's all them doing all those labs.
Yeah, nice.
Yeah. Yeah, like I said, I have not had time to go through and research any top of mind topics on my side, so I appreciate you pulling a few things together, Johnny.
Yeah, no problem. And I was trying to find more from especially upstream, but it's very quiet right now, which is it's weird. I get it. I think we were talking earlier, right? You said that's big PTO time in the EU, so makes sense. But
my wife is a healthcare worker. We never use the Q word.
Oh,
because that just jinxes it.
Oh, my bad. Yeah, I didn't say that.
Now we're going to start funneling all the things over to you in email and Slack. You're like, I don't know, it's Johnny's fault.
That's good. Yeah, go ahead.
Anyways, so let's talk about networking. Let's see, I want to share this window, I think. Hopefully that's visible. Let me change the geometry here to make it a little bit better. There we go. I'll eventually remember how to do this.
Yes.
There we go. Yeah, I want to try and align the geometry of the window share with the geometry of what we see here, so that way it's as large as it possibly can be. And then we'll also
looks good from here.
Turn off that. There we go. All right. So like I said, this is actually a Summit session. However, because this is not Summit and this is not a presentation, it means that we can kind of go through this and we can chat about things as we go and all of that. Feel free to interrupt, feel free to ask questions, all of those things, and we'll address them as we go. We also have the privilege of, we can always continue these sessions. We can always talk about things later and bring them back up and revisit things and all that other fun stuff. So we don't have to limit it to the 45 minutes that is that gets scheduled for Summit sessions. So with that in mind, let's talk some basics. I wanted to take or use this section to kind of cover, I'm going to say, low-level things, or excuse me, not low-level things, high-level things that are not unique to virtualization or bare metal in any way, shape, and form. And hopefully, if you've deployed OpenShift before, many of these things are things that are familiar to you. A lot of times, for better or for worse, when we create presentations that are virtualization centric, we assume that the person who's learning it is new to OpenShift. So for better or for worse, that often shows through with some of these, like I said, basics type things. Oh, here we go. So first, when we're deploying a cluster, networking happens in what I consider to be kind of 3 distinct phases, or network configuration, I should say. So one, when I go and instantiate the cluster, when I add a new node into a cluster, right, the first thing that's going to happen is it's going to look at that configuration that's being provided into it by something, well, basically by enum state in the configuration, or things like kernel parameters that are passed to it. So if you're deploying on vSphere, right, we have the, oh gosh, what is the name of the thing that feeds the IP configuration in, the VMX option? Anyways, there are various ways that we can get the network configuration in at a very early state, so that way we can configure what is ultimately that first set of network interfaces, the ones that are going to be used by BREX, which is BREX is the OVS that runs OpenShift, the OVN Kubernetes SDN. So BREX is where that lands. Typically speaking, the OpenShift nodes don't like it when the networking interfaces underneath BREX are modified post-deployment. Technically possible, but generally speaking, we avoid it. So we want to set that as early as possible, so that way, as it goes forward, it can configure all those things. So if I need to configure a bond, if I need to configure a VLAN interface, all that other stuff is set initially inside of there. As the node is going through and deploying itself, it configures BREX, the OVS on top of there. It moves the machine IP address onto BREX if it was configured somewhere else. And then it configures the rest of the SDN stack. Step 2, when we're talking about host level networking, is, okay, the cluster is deployed. I have my first interface, basically where my machine network sits, configured. Now I want to go through and do all of the rest of that configuration. So this is where I'm going in and configuring additional interfaces, bonds, etc., for whatever purposes I may have, right? Maybe I take 2 more NICs or 4 more NICs and create a bond, and on top of that bond, I create an OVS, and on top of that OVS, I'm doing other things, or I create VLAN interfaces. I have a VLAN interface for my IP storage and one for my backup and all of these other things. That all happens after initial deployment of the cluster. And then last but not least is the workload networking, right? Again, the session is focused on virtual machines, so we call it virtual machine networking here, but ultimately it can be used by any workload in the cluster, whether it's pod container-based or virtual machine-based. So that networking uses the underlying host networking in order to communicate, right? That's how we get out to the rest of the world. So I'll go through, in particular, section 2 and section 3 here is what most of this content focuses on. So the host networking part, my recommendation for, gosh, OpenShift 4 is coming up on 8 years old now, right? It was 2018, I think. I think it was 2018 was when OpenShift 4 was released. Maybe early 2019, I don't remember. Anyways, since then, my recommendation has always been that we want to keep the install as simple as possible, because we want it to succeed. If we can get through the install, then we can start to deploy things afterwards, and then if something goes wrong, we can troubleshoot it. If I package all of that into the install process, well, if the install process fails, it's now a much harder process to troubleshoot and rectify, or I just start all over again, which is a huge waste of time. So we want to keep that install process as simple as possible, and that includes the networking pieces. Configure just enough network to get it up and join to the cluster, and then push the rest of it down. So let's talk about BREX for a moment. First and foremost, you really don't have to do much here. It's generally configured automatically during the install process. Again, it takes that information that you feed it. So maybe that's enum state, maybe that's static IP information fed in through a kernel parameter, whatever. It takes all that information and it stands up that stack of things that are typically pretty hands-off. Yes, we can modify things like what is the size of the subnet associated with cluster networking and all those other things, right? SDN specific things, but I'm going to ignore SDN things for the bulk of this presentation and just work with the assumption that the SDN is there, and we can use it if we so choose. So the big thing I want to talk about on this particular slide is that bottom bullet, which is, typically speaking, we treat and want our costs, each one of our nodes, to be treated as an appliance. And that includes, in particular, the machine, for the context of networking, the machine network IP address. So it is possible, and there's a link here. I'll click on this link so you can see the documentation here. So it is possible in a kind of roundabout way to make some configuration changes. I'm sad that it didn't jump to the correct section, but that's the way the docs are sometimes. Anyways, some changes are possible, but things like changing the machine IP address, we're going to want to redeploy that. If I need to make major changes, right? It was originally deployed it to a single network adapter where it built BREX on top of that. Now I want to move to using a bond, or I want to change to something else. That we would typically want to do through a full redeploy of the node. Mostly because it's probably going to be faster. If I'm being honest, it's also the safer way to do it. Let's see. So the last slide in this section is more a reminder to not just myself, but everyone, of virtual machines can connect to the pod network, right? They can use the SDN just like any and every other workload running inside of the cluster. To me, this is something, because oftentimes we're coming from a virtualization environment that has direct layer 2 VLAN backed connections to the rest of the world. We don't often think about this. And so this is my reminder of, hey, if your application, if you're using external network things to provide separation and isolation into certain workloads, maybe you don't need to do that with OpenShift. You can create, and we'll talk about these in more depth in a few slides, you can create things like user-defined networks to provide that isolation, and it all works inside of there. I can use the standard SDN, network configuration and capabilities for connecting all of my components together without that networking having to, rely on external, upstream hardware switches and stuff like that in order to do it, right? I don't need proliferation of VLANs to provide isolation for my database servers, for my web servers, for my app servers, for my whatever servers. I can do that all natively inside of OpenShift. So it is an opportunity, if you're migrating into OpenShift and OpenShift virtualization, it is an opportunity to rethink some of those things if you've done them in other ways before. That being said, I'm also aware that sometimes we get ourselves in trouble of OpenShift, and we do this with all of our Red Hat products, right? Jonny, you were a consultant for a long time. They're so flexible that the answer is almost always yes. Like, oh, I want to do this. Well, yeah, I can do that. But that doesn't mean it's necessarily the best option or the easiest option. And sometimes we forget to go back and be like, well, what are you trying to do? And maybe there's a better way of doing it. So yeah, we do have to be careful sometimes. So for virtualization folks, this is probably the way that you have looked at networking for your hosts and your virtual machines for the last 20 plus years, right? Jonny, you're very familiar with this as well, right?
Oh yeah.
I have this concept here in the middle of, can I mark on this? I cannot mark on this. I have this concept here in the middle of my virtual switch. Inside of OpenShift, that's going to default to being called BREX, and it is an open virtual switch, OVS, that is running inside or on each one of the nodes. From there, I have the uplinks for that OVS, for that virtual switch. In this instance on the slide here, you see it's called Bond 0. This is the underlying host network. And then I have some number of other workload type things, including host networking, that connect through that Open vSwitch to get out to the rest of the world. So this is sort of our default view, the way that we tend to think of things. And what I want to do is kind of work through what some of these scenarios look like and some show how we can configure those, not at the low level, not like here's the network or not YAML, like here's the YAML to implement this, but rather conceptually, here are the things that we can do and what that might look like in OpenShift. So let's start at the host networking pieces. So generally speaking, everything that you know and have learned about, host networking, bare metal networking over the last however long IP networking has been around, they still apply. This is one of those things, and I think I said this during the storage, when we did the storage presentation, of OpenShift is Kubernetes on top of RHEL, or on top of RCOS, which is really RHEL, right? At the end of the day, it's RHEL. And it has and it inherits all of the same Linux concepts and constructs and capabilities, just usually with several layers of abstraction in there to make it quote unquote Kubernetes native, right? Kubernetes native here is basically referring to, oh, I can use Kubernetes, API, YAML objects, operators, right? Those concepts inside of there to abstract the management and implementation of those things. But at the end of the day, in the case of networking, it's RCOS, which is RHEL, using Network Manager. And if you're so inclined, you can go onto that host and you can use NMCLI and you can view and even modify that networking. But like all things inside of OpenShift and RCOS, it is expected to be managed by the platform. So if I go in there and I start doing NMCLI commands and modifying things, the next time that node restarts, it might not retain that configuration. The next time that an update is applied, because it's RPM OS tree based and it just overlays a new set of file systems, that configuration might not be retained because it expects that configuration to come from the control plane. But yeah, at the end of the day, it's still just Linux. It's still just RHEL. All that being said, so Linux bond modes are, various ones are supported. Again, this is specific to virtualization. So that KCS article that's linked there, 67546, refers to which Linux bond modes are supported for virtual machines specifically. At the host layer, you can still configure things like a mode 5 or mode 6 bond if you have some other type of traffic that can take advantage of that. So this is just ones that are supported or not supported for virtual machine-based traffic. The bottom bullet of that sub-bullet is important there. With some of these, you do need to have upstream configuration. So think mode 2, the balance XOR. This is basically a static port channel configuration if you use Cisco technology or terminology rather. It requires the host, the upstream switch, to be configured for equivalent. The ports have to be the same. The hashing algorithm. Wow, that was hard to say. Has to be the same. All of those things. Whereas a mode 4 bond, which is effectively LACP 802.3AD, will oftentimes auto configure so long as things are close enough, right? They'll negotiate. The other thing to be aware of when we're using OVS, when we're using Open vSwitch, is Open vSwitch itself can do bonding of network adapters. So we have traditional Linux bonds, right? These have been in the kernel forever. They've been around for many, many years. But OVS, as a logical virtual switch, has an ability to do its own bonding as well. So active backup is pretty straightforward. Balance SLB is pretty similar to XOR, so mode 2, and some of the capabilities in mode 4 or LACP. So the next slide here kind of walks through what are some of the differences with those. When should I use one versus the other? So I'm going to kind of go column by column vertically here. So mode 2, right, balance XOR. This is, again, I tend to refer to it or think of it as static port channel or static ether channel if I'm using Cisco terminology here. So this is where I declare, oh, I have 2 or 4 or however many links in this bond or in this port channel, and I'm going to use a specific hashing algorithm that uses certain data about the packets in order to determine which link they're going to use. So you can see there the default hashing is to use the source MAC address XORed with the destination MAC address XORed with the packet type ID, and then I modulo that against the link count. So what happens is, for my laptop and Johnny's laptop, they both have the same MAC address. If I'm doing just a regular, TCP packet or something like that, every communication between our two devices as it crosses a particular mode 2 bond is going to resolve to the same link, right? It's always going to be, ETH0 or ETH12 or whatever that happens to resolve to. So that is important because it means that point-to-point connections can only achieve the maximum throughput of a single link inside of that bond. Right? It's not like fiber channel, right? Fiber channel, I can take, 4 16 gigabit fiber channel adapters, put them into a channel, and now I have 64 gigabits of fiber channel throughput. With a mode 2, mode 4, balance SLB, right? With these IP-based networking, because it hashes, it means that I'm only able to get, for a point-to-point connection, the maximum throughput of a single link inside of there. So that second row, flow pinning, is what that is referring to. Moving down the columns, or excuse me, down the rows here, for that column, static lag is required. This means that I have to coordinate with my networking team to configure it upstream. And then importantly, transmit link rebalancing is not available, right? Whatever link that comes in on, on the reverse, the return, or the send, whatever that resolves to is where that traffic will always be. The OVS balance SLB, on the other hand, is going to be a little bit different. So let's ignore the hashing. You can see it's pretty straightforward there. Same thing with the flow pinning. The difference is with balance SLB, it is going to take all of those hashes and is going to bucket them. It's going to put them into, I think it's 255 different buckets or 256 different buckets. And then it takes those buckets and groups them together and assigns them to uplinks that are available. Balance SLB, I'm going to call it a bond, even though it's not a bond because it's not. Anyways, it assigns them to members of that group, right? And what it does is that transmit link rebalancing is every 10 seconds, it looks at the amount of outbound throughput available or that's being used on each one of those links. And it will move those buckets between the links in order to attempt to achieve balancing on transmit traffic going off of the host. So importantly, that's just transmit throughput. It is not receive throughput, right? It can't control how the network is sending us traffic. The big difference, or the other big difference there, is you'll see the third row rather, the uplink switch configuration. There is no uplink switch configuration that's required for balance SLB, right? It'll send the traffic out on whichever one of those it's doing, and then the traffic comes back probably on the same link because network traffic is based off of MACs, and it's going to say, oh, the destination MAC is on that end, so it sends it there. So all of that to say, how do you choose which one of these you want? Testing. My answer to all of these questions is always, test, validate, check which one best meets your requirements, which one allows you to control and manage the throughput, both receive and transmit for your workloads, and ultimately work with it from there. The good news is, if you're configuring this day 2, right? So remember I said post deployment, you can always change it. Right? There's nothing that says that you can't change those things and have it use something different. I just saw a question there. Is there documentation where we can find all the components that OpenShift is composed of? I know OpenShift uses Kubernetes. At one point, there was I want to say it was a blog post. It was like 3 or 4 years ago that listed a number of the major projects, like CNCF projects that are used inside of OpenShift. But I don't know if it goes, how far down the stack it goes. This is one of those things of like, have you ever heard of the paradigm about measuring coastline? Like, so like measuring the coastline of a country or an island or anything like that is basically impossible, because the more detailed you get, the bigger it gets until it like scales to infinity effectively. So at like a certain resolution, right, 1 mile granularity, if I take it in 1 mile chunks, it's going to be like 40 miles of a coastline. If I go down to 1,000-foot granularity, well, now there's, you know, a bunch of curves that suddenly appear, and now it's, you know, instead of 40 miles, it's now going to be, you know, the equivalent of 80 miles of coastline. If I go down to 1-foot granularity, and so on and so forth. And I feel like OpenShift is kind of the same way. If I look at it at the top level, well, there's 30 or 40 or 50 different CNCF projects. And then each one of those is going to use different open source libraries and components and capabilities that are themselves built off of all of these different things. So yeah, sometimes you have to, without overcomplicating it, you have to know when to draw the line on how granular you want it to be. I think I covered everything on this slide. Long story short, use the one that makes the most sense for you, for your workloads. Make a best guess, you know, best effort guess when you're starting out, and if you need to change it, you can change it. I'll talk about why or how to change it in a few slides, but the long story short is we can manage each node's network configuration individually. So therefore, we cordon drain, we change all of these things, and so long as the piece that the user networking, or excuse me, the workload networking is using, which is the bridge mapping, stays the same, then it just reconnects back in, and we're able to do those things.
Yeah, I was looking at this, and like when it reminds me of like when I was deploying OpenStack. If you don't get the network right on the physical side, it is just going to be a world of hurt when you try and deploy something. And it's the same thing here, right? Like once you have to like map what you have on your physical connection into your cluster, that's where like your point about keeping it as simple as possible, that is probably like the best advice you could give somebody. Just keep it as flat as possible, and then add everything on that you possibly can, because I'm telling you, 100% of the time the network guys are going to be like, no, it's completely correct. It's you. And then it could just be like one little configuration that they need to set that's not identical across all 4 channels, and it's just a nightmare.
Yep. Yeah, I remember losing a solid 2 days of my life to troubleshooting an issue that the network guys swore up and down, like every way from Sunday, that it was our side, it was our fault, it was our problem. The problem was we were encountering, we were using iSCSI for storage. And even though we had 10 gigabit networking everywhere, we were hitting a limit at 1 gigabit. And it was like, couldn't figure out. Eventually, 2 days later, after we ripped apart everything that we could in our configuration in order to prove that everything was right, turned out that they had forgotten that there was an inline firewall device, transparent firewall, that had 4 1 gigabit network adapters. And so it was the bottleneck for everything going through. It's like,
yeah, that sucks.
Yeah,
I had one. I was deploying OpenStack, and they had DHCP running on their network device, and they thought everything was coming from like a Windows server. And I was like, dude, something else is answering. They're like, no, it's not possible. They're like, there's no DHCP servers there. And then come to find out, they had it actually set up on the router. And it's another one of those like where you're there until you know how we used to work back in the day, trying to get it figured out till 1 in the morning, 2 in the morning.
Oh yeah.
So,
this is why they are our friends, not the enemy, right? They are often in the thick of it with us. So I used to do a presentation about that when I was at NetApp, when I was doing storage things, of like, make friends with the network admins, right? They are our friends. They will help us troubleshoot things. They are not intentionally antagonistic or trying to make your life difficult.
Yes.
So let's look at a couple of different common configurations that we see. Again, I'm not going to go way down into like implementation level details here. These are just architectural high level things that are pretty common, and I'll touch on a few different things about each one. So the first one is a shared interfaces, shared bridge configuration. So starting on the far right-hand side, we have the physical network configuration, right? Maybe I've only got one bond. My node has two 100 gigabit networking adapters, and I put those into a bond, and that's what I'm going to uplink everything through. So I have my BREX, my primary OVS, and from there, I am able to configure all of my various networking components on top of BREX. So VM networks here, if we want to jump ahead a few slides, these are effectively network attachment definitions, or UDNs, right? User-defined networks that are running inside of there. I just specify whichever one of my host networking devices I want those to run on top of. With this particular configuration, the important thing to be aware of is what's in bold there, which is the assumption here is that there is a native network and then probably some VLANs that are also being trunked into the host. So when I have that native network present, and that native network is the network used by the machine IP address, this is the configuration that I would use for that. However, if that interface, if the networking is trunked, there is no native network, or the native network that I want to use for my machine IP address or the network I want to use for my machine IP address is not the native network, then we would have to go with something like this. The difference here is that, again, on that far right-hand side, I've configured my bond 0, and now I've created a VLAN interface, bond 0.123 for VLAN 123. And that is what I build my machine network, my SDN BREX on top of. So all of the other workload traffic, right, if I need to access other VLANs and stuff like that, is happening through a second OVS that is configured and attached directly to bond 0. So a specific interface at the host level, right, whether it's bond 0 or a VLAN interface or an individual network adapter, it cannot be used by more than one logical switch simultaneously. So I can only do a one-to-one relationship there. That's why, here I have everything in one OVS, whereas here we have multiple OVSs. They're just connected to different host level interfaces. I think I touched on everything that's here. Security-wise, if it's important, you'll see that top bullet, BREX in this instance, is not able to see other VLAN tags. So if you did have, if you wanted to configure something on top of BREX that needs to access another VLAN, in this instance, because it's on that VLAN interface, those tags are not going to get passed through. It's not going to work. So now we're getting into what I consider to be a little more common when we don't have, super high-speed network interfaces. I think a lot of folks these days are, probably multi 25 or 40 gigabit network interfaces. I probably, at least 2, if not 4 or more of those interfaces. And sometimes, if I think back 20 years when I first started doing virtualization, right, we'd have, gigabit interfaces for quote unquote management and 10 gigabit interfaces that we divide up and use for things like storage and virtual machine networking and all that. These are the types of scenarios that where I have a proliferation of NICs where this becomes important. So this is ultimately very similar to the last one, right? The difference is my bond 0 here is now dedicated to BREX. Maybe that is a pair of network adapters or however many network adapters that don't have any trunking. It's just the single native network. Maybe there is a separate set of VLANs that are trunked in there for whatever type of traffic that happens to be, right? Hey, I'm going to use BREX or bond 0 and the networks that are part of it for my backup traffic or for my live migration traffic or something like that. I want to put my storage traffic and my VM traffic onto bond 1, right? All of these things are completely possible and capable inside of there. It's just how do we organize them from a logical perspective. I think this is the last slide in this one. So this is where we start to increase maybe increase isn't the right word, but this is where we start to add host level networking that is not used by the workloads necessarily. So first and importantly, remember this is all Linux networking. And so when we get down to the level of like, here I have this live migration and backup traffic. So backup traffic, I'm probably talking, over to some sort of storage device that it is backing up all of that traffic to. So my host needs an IP address on that network. We configure all of that up using nmstate. Everything works great. And then I go to implement, and suddenly it's sending traffic out of the machine network IP address, and it's not able to connect to my protected backup network. It's because it needs a route rule to be put in place. Right? If I'm having to route, if my backup or my storage or whatever traffic isn't layer 2 adjacent at the host level, I need a route rule. Otherwise, it'll use the default route, which the default route always uses the machine network for RCOS. So that's kind of the big thing to take away from this is, at the end of the day, remember Linux networking. And so all of my rules for Linux networking still apply and still need to be used for controlling how traffic, it ultimately leaves and enters the host. One weird exception here, or one, not an exception, but an interesting one, is the live migration network. So contrary to basically every other virtualization solution that's out there that allows you to isolate isolate live migration traffic, including like Rev, the host would have an IP address on the live migration network. And when I go and I trigger a live migration, it talks host to host, and it moves that memory data and state data and everything else for my virtual machines between them. With OpenShift virtualization, the host doesn't need an IP address on that live migration network. And the reason for that is because it's the virt controller that is doing that inside of there. So effectively, it adds an IP address to the live migration network on the virt controller pod that's running inside of the host.
Oh, that's cool.
So that live migration network, the hosts need to be able to talk to each other. Basically, they need layer 2 adjacency, but you can let the cluster do the IP address management for you. You just choose one of the IPAM methods available inside of there and tell it to go and do its thing, and it'll connect everything together. So yeah, I thought that was an interesting one as well. Of just the way that we handle that is different because containers and pods.
Yeah, no, that's pretty cool.
Flyjack, went through some of this kind of setup during a proof of concept on hosted control planes, facing some routing difficulties. Do you have some artifacts somewhere showing the configuration items to be applied in addition to the documentation? Flyjack, when you say artifacts showing configuration to be applied, are you referring to like host level networking in general? Are you referring to hosted control plane networking and what that looks like, which is a whole nother bottle of worms? If you can just give us some details on that, that'll be helpful. We'll do our best to answer those and point you in the direction of any resources that we're aware of. So virtual machine networking. So if all of that was talking about how we're configuring the host and the host networking things out to the rest of the world, now we want to talk about how we take our workload. Again, this is a VM-centric presentation, but really it works with any workload inside of OpenShift. How do we take those things and through the host level networking connect them out to the rest of the world? Host network config like the NNCP items. Yes, there is some examples that we can share. There's a bunch of blog posts on them. We can dig up some things. Jonny, I see you're typing away. I'm sure you're searching for them.
Yep, I was gonna try and find them.
Okay, while we're on the stream, we'll share as much as we can. If not, you can always reach out to us. I think Jonny and I both have our email addresses up on the screen there. So let's talk about virtual machine networking. So this is, again, how we're connecting workload to the outside world built on top of that host level networking stuff that we were just talking about. So first, kind of before we even get started with connecting the workload to the outside world, there tends to be like a whole lot of questions that we have to ask ourselves. This is one of those, like in typical OpenShift fashion. It's not all of Red Hat, but it's especially bad with OpenShift. Like before we can get started, we have to know all of the answers. I say this like with cluster instantiation, right? Because once I start the install, it goes through to completion or it doesn't. And if it doesn't, I don't have an opportunity to go in and like reset and try again, or just troubleshoot and fix this one thing. Instead, I have to undo everything that it did and restart from zero. Networking can feel that way at times. And so because some of these things can be complex to implement and manage, we feel like we have to answer all of these questions inside of here in order to really begin implementation. As I said before, this is one of those areas where we don't have to do that, right? We can start with configuration A and realize that, hey, this isn't working for me, or I forgot to add this, or I forgot to do this, and we can modify that. We can change it all day too, and it's okay. Really the biggest exception there, and towards the end of these slides, I have the list of things that we can't change or can't easily change. But like all of these workload connectivity things, we can generally change day two. So I'm not going to review each one of these because we'll work through them as we go through different slides. So let's talk about user-defined networks. If you've been following OpenShift virtualization for any length of time, you've seen an evolution of how we communicate, or how we connect virtual machines out to the world. Right? OpenShift virtualization went generally available back with OpenShift 4.5. At the time, the SDN was OVN Kubernetes, or excuse me, was OpenShift SDN, and I don't know that we supported OVS, like separate OVS at the host level. And so what you saw was our initial recommendations were things like, oh, create a Linux bridge on the host, and then use that Linux bridge, just like you've done Linux bridge for ages, in order to connect your virtual machines out to the world. We saw some users that would create, or customers that would create multiple VLAN interfaces, right? I've got VLAN 1, 2, 3, and 4, 5, 6, and 7, 8, 9. And on top of each one of those interfaces, I would create a Linux bridge, and then I would attach my VMs to those. So we saw kind of this proliferation of, and I keep using that word today, right? This explosion of different network configurations inside of there. I want to say OpenShift 4.14 was when OVN Kubernetes became the default for OpenShift. I think it was 4.10 or 4.11 was when OVN Kubernetes became supported. 4.14 was when it became the default. And as of 4.18, OpenShift SDN, or maybe it's, I think it's 4.18, it might be 4.19. OpenShift SDN is no longer supported. You can't even deploy it inside of an OpenShift cluster. And so we went from use Linux bridge to use OVS with manually managed network attachment definitions to now in 4.18 and later, user-defined networks are the preferred method. This has remained, I'll say, mostly static. I'll talk about a few exceptions here at the end. But generally speaking, for most use cases, we encourage folks to use user-defined networks for their virtual machines connecting to each other and to the outside world. So let's talk about UDNs. I'm going to walk through some of these things in some more detail. So this is just a high-level slide. The only columns that I'll talk about here are the workload and tenant isolation. Basically, when I create a layer 2 or layer 3 UDN, that by default is isolated to a specific network, or excuse me, a specific namespace. And I cannot communicate between those UDNs, between those namespaces, without explicitly allowing that communication. So from an isolation standpoint, it's a good default stance to take. The other one that I'll talk about on the far right-hand side is the Kubernetes APIs. So effectively, it's a full implementation of the feature set of associated capabilities and things. So think, oh, I need to create a service. Well, it's riding on top of UDN. It just works as expected, including when the UDN is doing IP address management. Network policies and admin network policies apply. I can configure egress IP, right? All of the things that I come to know and love from my network stack work with UDNs exactly the same. So the first thing that I'll talk about in the concept, or two things in the concept of user-defined networks, is there are two different scopes and two different roles for each one. So generically, we call the feature and the capability user-defined networking, and then we overload that term by calling one of those scopes UDN as well. So a user-defined network, a namespace scoped user-defined network is the default. And this is created, it is only available, accessible within that single namespace. And again, traffic ingressing into that namespace from other namespaces needs to be explicitly allowed. So a couple of things there, you see it does not support VLAN tagging if I'm using a namespace scoped user-defined network. A cluster-defined user-defined network, on the other hand, I can have more than one namespace attached to, and they are all effectively peers inside of there. So if I create a layer 2 CUDN, cluster user defined network, all of the namespaces that are connected to that are going to share the same layer 2 broadcast domain inside of there. Networks or namespaces outside of that don't share that namespace. And I don't remember, I'd have to double check and see if like the same, I think the same egress policies, or excuse me, ingress egress policies for access from outside and into a CUDN still apply. So the other thing to know about UDNs is they also have different roles inside of the namespaces that they are connected to or associated with. Excuse me. So first is primary. So if it is a primary UDN, it effectively replaces the SDN connection for the workload that's inside of there. So by default, if I don't have a UDN or if I configure a secondary UDN, when I create a pod or create a virtual machine, it connects to that the SDN, so OV and Kubernetes by default. With a primary, so it connects to the SDN by default, and then I have to explicitly tell it to also connect to a secondary UDN. With the primary UDN, it connects to that UDN by default. And then I have to tell it to connect to any other networks manually or explicitly. So this is important for a couple of things. You'll see as you look across the different bullets or sub-bullets here, certain features and certain capabilities are only available with certain roles and scopes, right? So if I want to do VLAN tagging with my user-defined network, I can't have a namespace scoped user-defined network. I have to use a cluster scoped user-defined network. If I want to use BGP, I need to use a primary network UDN, regardless of whether it's cluster scoped or namespace scoped, right? If I want to use LocalNet, which we'll talk about in a moment, I have to use a secondary user-defined network. I can't use a primary user-defined network if I want to use LocalNet, so on and so forth. I have a really helpful chart here in a moment. So layer 2 and layer 3, these are both interesting, but they are interesting in the grand scheme of things. They're really powerful, really capable. For virtual machines, we typically care more about LocalNet, which I'll talk about on the next slide. R9, thank you for pointing out it was 4.7 that OVN support was added. So layer 2 is, as the name implies, it is a single layer 2 broadcast domain that's available to all of the things connected into that UDN. So I would create my new layer 2 UDN, and then I give it a /20 or a /18 or whatever set of IP space I want. And then regardless of which node in the cluster my workload is deployed to, be it pod or VM, they all pull IP addresses or all use IP addresses from that same scope. So anywhere, everywhere in the cluster, it's all broadcast domain, the same broadcast domain. Layer 3, on the other hand, behaves more like how OVN Kubernetes works, where each one of my nodes is given a subnet from the parent block that has been assigned. And then as my workload, as my pods get instantiated on different nodes in the cluster, they receive an IP address from that particular subnet. So importantly, this cannot be used with virtual machines. So you see not compatible with virtual machines, because if my VM were to live migrate, the IP address would change. With a layer 2, that VM gets an IP address from that layer 2. As it moves around to different nodes in the host, it retains that IP address. So LocalNet is the one that we see very frequently, particularly when I want to do external VLAN backed networks. This is the way that we do that. So LocalNet here is basically saying which local network device on the host is this network passing traffic down to, right? So you can see in the top bullet there, local or direct access to an underlying host network. There is no overlay that's being used for it, right? If I have a VLAN available to me, then it is passing that network traffic down through the host network stack and out to the world using that VLAN interface. So this is where, again, so far, the bulk of virtual machines, right, when we look across our implementations and customers who are deploying OpenShift virtualization, this is where the bulk of virtual machines are connecting to, or how they're connecting rather, to the outside world. So a couple of things to notice here. So LocalNet has existed, this concept and this capability has existed since before user-defined networks. So this bottom primary bullet is what addresses that. It is the same. The difference is with user-defined networks, the operator and its controller are managing the network attachment definitions for us. So before, I would have to go in and for every namespace that I want to be able to connect to, my VLAN 7 underlying set of devices or underlying network, I have to go into each one of my namespaces and define that network attachment definition and make sure that all of that's there. With UDN, when I create my cluster UDN and I say I want namespace, A, B, star, delta, and square to all have access to this, the operator, the controller creates and manages those for us. So it's dramatically easier. in that regard. So this is the promise chart that breaks down all of the feature mix and matrices and capabilities in order to highlight when and where we might use different ones. So first and foremost, you can see topology, layer 2, layer 3, local net, the role, so primary, secondary, and then provisioning CRD is whether it can be used as a cluster user-defined network or a user-defined network, namespace scoped user-defined network. So kind of the highlights here, all of the things that I've said before. You'll notice that the local net, physical net can be used with virtualization. However, we do not support IP address management on those local net devices. It's expected to be consumed or available from the external network, whatever is managing that external network. We're just passing through. If I want to advertise, if I want to use BGP for connecting my workload out to the outside world, right? I have pods or virtual machines that I want to connect directly to the outside world and have BGP manage the routes for me. I have to use a layer 2 or a layer 3 primary UDN in order to do that. Sorry, primary cluster UDN in order to do that. And note that layer 3 is not available with virtual machines. So this is the one that I typically recommend folks take a screenshot, if we're at a conference, take a photo of this slide because this is the handy dandy reference one. So I want to switch over before I get into this other VM network options, and I want to kind of illustrate a couple of things that I hope make this a little bit easier to understand. So I'm going to try and draw this freehand using my mouse, and I'm going to try and make it large enough so that everybody can see it on their screen. If it doesn't work for whatever reason, please speak up in the comments and I'll do my best to improve it. So let's talk about some networking concepts, right? So at the host layer, I probably have something like a series of network adapters, and my squares or rectangles are going to get messier if I'm not very deliberate about this. So I have my network adapters here, right? And then I'm going to take these and I'm going to build them into a series of bonds, right? See if I can concentrate hard enough to write letters.
Doing great, kid. You're doing great.
It's what is the Apple thing? The Apple Pencil and the iPad where you can like do these things. Like, wouldn't that be great right now?
It would be amazing, yes.
Yeah, and then on top of here, we optionally have things like VLAN interfaces if I want to do something like that. So I could have a VLAN interface down here for VLAN 12 or something like that. And then on top of that is where I'm going to create my logical networking, my switches. So I'm going to go with an OVS column here. So I connect this up to an OVS, and my OVS is where all of that, right? This is all host level networking things. All of these things are defined in an NCP, right? So all of that is managed through NNCP. Including on an OVS, there's a very important thing here called a bridge mapping. I'm going to use BM abbreviation here, just because I'm not going to write out bridge mapping on here. So the bridge mapping becomes effectively the pivot point between my host networking and my workload networking. So what that means is, maybe this is, this networking configuration that I'm looking at here with 4 network adapters feeding into a bond that connects to my OVS. Maybe this is, my, I have a group of 4 nodes that have this networking configuration, and then in my cluster, I have another group of 4 nodes that have a completely different networking configuration, right? Maybe they've only got, can I make multiple? How do I create can I do another one of these canvas? So new drawing. So let's say I've got another one that is just 2 network adapters on here, and then this feeds into a bond, and then that bond then has a VLAN interface, and that VLAN interface then has an OVS, right? And then I also have an OVS directly off of here. Wow, my writing is getting worse and worse. So this is BREX, and then this is my workload, right? Completely different in NCP. so long as the bridge map that's here has the same name as the bridge map that is used here, the workload network doesn't care. Right? So this is where when I create my network attachment definition and I specify the FISNet, that is that pivot point. So another way to look at this is, so let's go home, let's create a new drawing. So I've got my host networking config, right? Wow, that was truly awful. So I've got my host networking config, right? So this is an NCP for, group 1. And then I've got my group 2, in NCP. That's far more difficult the second time, right? So long, it doesn't matter what these look like, so long as at the end there's an OVS that outputs to an equivalent bridge map, right? And that bridge map becomes the quote unquote pivot point. I can change all of the underlying networking associated with it so long as at some point there's a bridge map. And then that bridge map is where our net attach def lives, network attachment definitions. I'm not going to write out ATTACH, but the abbreviated one in the API is net attach def, right? Because they key off of this thing right here. And if I need to change the underlying host networking, so long as I recreate that bridge map, I'm good for connecting my workload out to the rest of the world. So that is kind of the key thing that I want to communicate here is I don't have to have homogeneous networking. I can have as many different network configs as I want, host level network configs as I want across my entire fleet of servers, so long as from a networking perspective, I end up with the same bridge mappings so that my network attachment definitions, which is going to be like, VM net, 12, right? So long as it can map into that particular device, then I'm good. So that's kind of the important and critical parts that I want you all to take away from that particular section of things. Over here is where I'd have my network attachment definitions over here, and then I have however many of these that I want inside of here, and they all map back to the bridge map. Importantly, with these, this is also where my VLAN definition is at. So I have VLAN 7 and VLAN 9 and VLAN 110, right? So on and so forth. The tagging is done. The VLAN tagging is added and removed at the OVS level. So I can have multiple VLANs all running through the same bridge map. Note that changed in the 4.18, 4.19, 4.20 timeframe. It used to be that each network attachment definition had to have its own bridge map. They fixed that. It's been a little while since we fixed that.
So you're saying in your network attachment, you tag the VLAN there, and then it hits the bridge, and the bridge is already bonded, but it's already got it's already trunked or whatever, so it just plugs it out. Okay, yep. Nice.
Yep.
Nice.
Yeah, and importantly, so we use the network attachment definition, which is what defines like the network configuration that's applied when the virtual port is connected. So if I have a VM, right? So I don't know what thing to use to define a VM. I'm going to call that a VM. So my VM is connected into here, but really the network attachment definition isn't in the path. It's just configuration information. The data path is actually directly into the OVS, right? And so when traffic leaves, when packets leave this virtual machine, they hit the OVS, and at that point is where things like network policy and VLAN tagging happens. And the inverse is true as well. As when the traffic arrives into the OVS, it has, network policy would be applied again, as well as that's where the VLAN tag is stripped off and it's sent over to my endpoint device. So sometimes we'll be asked, like, because other vendors use different terminology, so it's like NIC, like where is network policy microsegmentation applied in the traffic flow? Is it at the VNIC or is it at the vSwitch type of thing? Well, it's like asking I'm plugging one end of my network cable into my server and the other end into my switch. Where is that being applied at? It doesn't. It's happening in the same place. It's just which end of the wire am I talking about? Yeah. Any thoughts on that, Jonny? Any questions?
No, I think this is awesome. It's cool. I actually had a question about the VLAN tagging, but you already you answered it with the network attachments.
Yep. Hopefully all that makes sense. So one thing with if I create other like the layer 2 UDNs or layer 3 UDNs and stuff like that, they still have network attachment definitions that just define connecting into those devices that then they're just logical things that ride on top of the Open vSwitch, BREX. Yeah, please do send us a message, Flyjack. I appreciate that. So that's user-defined networks. That's OVS and sort of connecting out to the world using that. Like we said before, there's never only one option for doing all of these things, right? So what are some other options that we have available to us? So first, can you do OVS without doing user-defined networks? So prior to user-defined networks, so pre-4.18, and if you look at the architecture guide, which was written right as 4.18 was releasing, the architecture guide was still a little uncertain of UDNs at the time. So pre-UDN, you were effectively doing the same thing. It's just, so these network attachment definitions were defined manually instead of managed by the UDN. Effectively, it is literally the exact same thing underneath the covers. You're just allowing this controller to manage the network attachment definition configuration instead of some poor human having to do it. Which I say some poor human, I don't know if you ever looked at a network attachment definition. It's JSON embedded in YAML, and it sucks.
Oh, that's awful.
Yeah. So I always encourage people like don't do that by hand unless you just really hate life. Oops. So yeah, automatically manage the network attachment definitions. You can see here I'm highlighting that network attachment definition syntax is finicky, right? So just be aware of that. So Linux Bridge. Linux Bridge has existed for a long time. Much like cockroaches, I suspect it will always exist in some way, shape, or form inside of Linux.
Yeah.
And it still has, like, it is an absolute legitimate way of doing things, right? There's nothing wrong with doing it. However, there are pros and cons associated with each one. So pros, you can absolutely do things like guest level tagging. So remember with OVS, I was saying that the tags are applied at the OVS or stripped and added at the OVS level. With Linux Bridge, I can pass through those tags to the guest. So this is really important if I have, for example, virtual firewalls, right? So VNF, CNF type workloads, and I need to pass through those VLAN tags and allow whatever that appliance is to do its thing. Note that I think that changing that or allowing guest tagging, trunking into virtual machines and pods is on the roadmap for OVS or OVN Kubernetes / UDNs, but I don't quote me on that. Same thing for IP spoofing protections, right? VNFs need that type of thing. Port isolation, basically this means, if I want to do prevent endpoints, right, virtual machines, pods, whatever, that are running directly next to each other from communicating with each other, I need to force that traffic up to a network device and allow it to apply like MAC filtering or something like that before it can come down. So hairpin routing. We can do that with Linux Bridge. The other thing, probably the most important thing, is the Linux Bridge is, from a throughput and overhead perspective, it is going to be the most performant with the lowest overhead. Right? OVS is amazing. It has a huge number of features, just an incredible amount of capabilities. Right? OVS came out of OpenStack. Right? OpenStack is used heavily in the telco environments. Right? It has just incredible capabilities, but those come at a price. And that price is a little bit of extra latency and a little bit of extra CPU. And by latency here, we're still talking like microseconds, but sometimes every little bit counts. And if I'm pushing 100 gigabit throughput and I am bumping up against, I need every single byte of throughput that I can get out of it, and I need to save every bit of CPU, Linux Bridge is going to be the way to go with that. But the cons are also pretty significant as well, right? Not compatible with UDN, okay, that's fine. No network policies, in my opinion, is pretty substantial, right? If I want to do, micro segmentation, if I want to control the traffic at the platform level so that, hey, my web tier can only communicate with my, MariaDB or MySQL databases, MySQL databases on port 3306, and I want to do that at the platform level. I don't care what those DBAs or what those web admins think. I'm going to limit it there. Like, we can't do that if we're using Linux Bridge. We need OVS or something that supports a network policy. I say or something. Like Christian is coming on next week, right? Christian is Cisco Isovalence, right? Isovalence supports network policies, all these other things. So does Tigera Calico, right? Along with several others. So you don't have to use OVS. You don't have to use OV and Kubernetes for those things. Our ecosystem of partners has a myriad of features and capabilities as well. The other thing to point out here with Linux Bridge, arguably one of the biggest ones, is that right-hand bottom bullet, which is Linux Bridge, from a roadmap perspective, is feature complete. So all of the new features and capabilities that are coming to OpenShift networking are being built on top of OVS, not on Linux Bridge. So if you need things like, for the moment, VLAN pass-through, if you need things like that extra, the maximum throughput with the least amount of overhead, like, yes, absolutely use Linux Bridge. But generally speaking, if you don't have a good reason, default to OVS. Service mesh. So service mesh is, of course, a thing. It kind of sits at a different layer, right? Service mesh is more of a layer 7 thing that interconnects all of my workloads together. So you absolutely can connect virtual machines into the service mesh, and you can interact with, consume, use all of the service mesh features just like you would everything else. Today, within Asterix, I say that because we have had an OpenShift release since I created this presentation. This is Summit timeframe, so 421 was state of the art. Now 422 is, so I don't know if it's still true. At the time when this was created, you could not join an external device into the service mesh. Basically, you configure the service mesh, and then when you join it to the service mesh, the SDN connected interface for that workload, whether it's virtual machine or pod, is what connects into the SDN. They had on the roadmap, and there's even a blog post. I'll have to dig it up and see if I can find it. There's a blog post that even shows like the tech preview feature of deploying the agent into a virtual machine, for example, and then it can connect into that SDN, even if it's not directly connected on the SDN. But yeah, service mesh is really cool, right? It offers a bunch of capabilities. Automatic MTLS, I think, is one of the coolest ones, right? We get all of the benefits of MTLS with traffic encryption, with endpoint verification, right? All of those other cool things, and I don't even have to think about it. It just comes out of the box and it's configured and available to me. Yep, I think that covers most of the things on here. Microsegmentation, I've talked about most of these things here. Probably the biggest thing to know about using network policies with virtual machines and the way that we do it with OpenShift is it operates at the layer 3 and layer 4 level. So layer 2 is MAC addresses, layer 3 is IP addresses, layer 4 is ports. So what that means is that when I create a network policy, I have to specify the IP, singular or a block of them, and the port or ports, singular or many, that are affected by that, both source and destination. So the difference there is with other solutions, including things like, I don't know precisely, but I can imagine that one of Tigera or Calico, or Tigera and Calico are the same thing, Cilium, right? They can do it differently, but it doesn't apply on the object, it applies on the IP address and the port. So I can't have like, hey, anytime you create a pod that has the name or the label Johnny in it, I want it to automatically have this network policy applied to it. That doesn't work at the OpenShift level. You can have something like ACM or even GitOps do that, But just having a singular network policy that says automatically look for this label. If it has that label, apply this policy. It doesn't work like that. Instead, it's based off of the IP address and port combination. Yeah, not available down at the bottom with microsegmentation. Layer 7 application-aware enforcement on VLAN-backed interfaces. That goes back to the service mesh is what provides the L7 traffic control, and service mesh, at least in the 421 timeframe, again, I don't know what it looks like today. I haven't updated my information. Could not work with a VLAN-backed interface. It had to be, the traffic had to be traversing the SDN. If they have shipped that ability, the agent ability, then that should be available now and possible now. And that dynamic policy targeting by VM tag or workload identity, that's what I was referring to a minute ago. If I can't create a network policy that says everything with this label inherits this network policy, that doesn't work with network policies. So in the last few minutes that we've got here, because I do have a hard stop at in the next 10 minutes or so. So just some high level things. Generally speaking, in modern days, we don't, in modern days, I say in the last several years, we don't recommend using host VLAN interfaces for VM connectivity. So the thing that's underneath the big red slash mark there is we don't want to create a bond and then, here, I think I drew it over here somewhere. I don't want to create or do, nope, one of these. Well, this is what happens. I don't want to have this thing, here we go, this is close enough, right? I don't want to have like a VLAN here, oops, VLAN, and another one here, and another one here, and another one here, and then create multiple Linux bridges on top, right? For each one of those, and then on top of here is where my workload networks sit. Instead, we want to take this approach of where the VLAN tagging is done here at the OVS level, so that way I'm not creating and managing all of these different interfaces and all of this different configuration inside of there. Will it work? Yes. Modern RHEL supports thousands of host level interfaces with minimal overhead. The difference is the amount of NNCP and other configuration that you have to manage becomes challenging. So the human is the problem in that case. You know, keeping up with all that configuration, deconflicting it, troubleshooting it, all those types of things. Dedicated versus shared NICs for different traffic types. Absolutely separate all the traffic that you want by whatever rules, reasons, and possibilities you can envision. Just note that there is nothing that is nothing that surfaces up the ability to do traffic or throughput control for different things. So what I mean by that is, let's see if I can find a good example here. So this OVS, and I know it's super, let's clean up some of my lines here. So at the OVS level, it has the ability to manage different traffic types or throughput, right? So I can say, you know, hey, everything that is coming in that has this configuration, I want to put a max throughput limit of 1 GB on it or something like that. But the ability to configure that is not exposed into OpenShift or Kubernetes through any of the abstractions that we have today. So it's an OVS feature. It is not an OVN Kubernetes feature, if that makes sense. So absolutely separate all of them you want. Just keep aware if you're actually sharing them at whatever aggregation level, there is nothing that protects the throughput for different workload types. So I put this slide in here, I think this is the last slide, about not forgetting about the SDN, because it can still affect some things inside of my cluster. So even if VMs aren't using it, right, I'm not connecting my virtual machine to the SDN for VM to pod or pod to VM or VM to VM traffic, it's still being used by different things inside of the cluster, right? Each one of my virtual machines is still, the underlying pod is still getting an IP address, still getting a connection to the SDN, because that's how it communicates with other things for management purposes. So think how it's communicating with the controller and all of those types of things. Communicates with the local, not vert launcher, vert controller, the local vert controller using a Linux socket, but it communicates with the control plane using an IP address. So it's still being used for those purposes. That being said, that's mostly transparent. We don't care about that. What we really care about is this SDN IP space and how that affects my cluster scalability. So we've talked about this. It's been a few years since we talked about it. At the cluster level, when I instantiate my cluster, I assign a subnet. So by default, it's a /14 to the cluster network CIDR. And then on the SDN, each one of the nodes that joins the cluster is assigned a subnet out of that for the pods that are running on that node, right? Going back to the layer 3 topology, same concept. So by default, if I don't change anything in my cluster, it's going to give me a /14, and each node in my cluster will get a /23. So there are 512 /23s that fit into a /14, which means that I am, by default, limited to having about 500 nodes in my cluster. If I try and add more nodes than that, it basically can't join the SDN because there's not IP space for it. So I can reduce the size of this, right? Hey, I need 1,000 node cluster. Let me reduce this down to a /24. But doing that means that I reduce the number of pods that I can schedule onto each node, right? It would go from 512 down to 256. Conversely, like, hey, I really want to be able to put, for some reason, I want to put 1,000 pods, right? I want 400 VMs and 600 pods to be running on each one of my nodes, or I want to have that ability. I'm going to change this from a /23 to a /22. Well, that just cut the maximum number of nodes in my cluster from 512 down to 256. So all of that, those are huge numbers. I don't think most people are going to be bouncing up against that. But a lot of organizations don't want to assign a /14, right? They want to limit this to a /18 or a /20 or even a /22. And that changes the maximum size of my cluster. And we have to balance out the size of the cluster network CIDR versus the size of the network that we're assigning to our nodes when we are changing those things. So just keep that in mind. You can see it's all but immutable. I can increase it, but I can't decrease it after the fact.
Yeah, we ran into that all the time. Like they did not want the huge networks. They just wanted to be like, a lot of them just wanted to do like a 23, and then be limited that way.
Yeah. Yep. And a lot of that is because, well, the cluster network, that IP space, this 14, can't be real externally routable IP space. Because if it is, that means that the pods don't know how to route out to something in the real world that exists in that IP space. So, and a /14 is a lot of IP space. Is this oh no, there's actually a couple of slides left. Okay, virtual machine networking recommendations. So back when I had the guy that was dropping all the limes, this is quick answers to a lot of those questions, right? Default to OVS unless you absolutely need something in the Linux bridge side of things. If you're using VLAN backed networks, right, I'm connecting my VMs or pods out to a VLAN, right, use a secondary cluster UDN. That is the default that we recommend now for basically all scenarios. If you're using microsegmentation, don't use Linux Bridge, use OVS or use one of our partner solutions. You can connect VMs to both the SDN and the service mesh if you so choose, including with multi-network attachments, right? I can have my VM that has a network adapter on a VLAN, VLAN 1 and VLAN 7 and VLAN 13, and then a fourth network adapter that's on the SDN. Nothing wrong with that. Just keep in mind your routing rules and which one it's using for which networks. And then, of course, if uncommon use cases down there, if you're doing VLAN trunking into a virtual machine, right, think a virtual network function VNF type of thing, then you have to use a Linux bridge, at least for now. NM state. So NM state, the biggest thing to remember about NM state is, unlike literally everything else inside of OpenShift and Kubernetes, deleting an NCP does not automatically unconfigure the networking that is assigned with it. Unconfiguring the network is a two-step process. The first step is to go into the NNCP and mark the configuration as absent, which will trigger it to remove that configuration. And then I can delete the NNCP object from the OpenShift control plane. So chatting with engineers, there has been the concept of maybe having an auto delete that configuration batted around. The problem is nm state also does not do ordering. Right, so if I have an nm state that creates a bond, or an NNCP that creates a bond, and then an NNCP that creates an OVS, and then an NNCP that does something else, and then an NNCP that does something else. If each of those, right, I have to have the bond before I do the OVS, I have to have the OVS before I create the bridge map. It doesn't order those in the way it needs to go. It might try and create the OVS before the bond is created, and then it ends up in a run condition, and it just sits there and doesn't know what to do. So we have to create all of our dependent configuration in a single NNCP. So if I accidentally delete the wrong NNCP and it unconfigures my host networking, I could affect a lot of things. And so the safe mechanism, and Red Hat, we tend to default to doing the safest thing possible. The safe thing is to force the user to manually remove that configuration, which is why you see it that way. And that is now the last slide that was inside of here. So I hate to yammer on and then drop on you, Jonny. I do have 3 minutes that we can close out. I'm happy to answer any questions, and of course, folks can reach out to us anytime if you have any questions, either here during the stream that we don't get to, or of course afterwards. I know a lot of folks watch these afterwards or listen to them as podcasts. So hopefully this was useful. It's been. Go ahead, Jonny.
Oh yeah, sorry about that. Yeah, I was just saying. Yeah, no, I thought it was awesome. I love. It's cool for me to see, like, all right, cool. You know, like the old school networking things that we used to set up, like all the pain, because I used to set up all the the bridge interfaces and the VLAN tags and all that stuff, and then it's nice to see where, all right, cool. Now I just have to set up in the NAT and then let the OVS do the rest, and yeah, that's pretty cool.
Yeah, I haven't. It's funny. This was again 421, so things like EVPN are new to 422, so I didn't include EVPN or any of that stuff in here. I didn't include Submariner or any of the other things that are in there, like BGP. I just flirted with the edges of BGP in here and what that means and what that looks like. The feature set of OVN Kubernetes and OpenShift networking as a whole is just it's really incredible. And it's funny, in our internal Slack, we have different channels for OpenShift and OpenShift virtualization, all these things. Usually at any given point in time, about half the questions are networking related, because it's an impressively complex beast, but it is critical to every operation. What good is an application that can't communicate with the world?
Yeah, and I like how we're kind of getting to the point where it's like, all right, we have our infrastructure networking, and then we have our application networking, and then not even talking about meshes or anything like that, but like the UDNs and having the ability to connect to the layer 2, layer 3, and then multi namespace. It's pretty cool to see how far it's come.
Yeah, and we for anybody who missed it, so when we did the what's new in 422, I think didn't we showcase a couple of the UI things around like creating virtual machine networks and stuff like that? I don't remember if we did or not. Anyway, if you look in 422 has some new UI things around networking. I will tell you that far and away the biggest UI UX complaints, or the most frequent, most prolific ones that we hear, are around the networking user experience. And there is a team of, I kid you not, like a dozen people who are working on these things like full time. So I had last week I was talking about, I'm gonna use the LLMs and vibe code up some examples and stuff like that. That's because yesterday I had a meeting with that team and we showed like, hey, this is what I have in my head, right? It doesn't mean anything outside of my head, but here's how I envision some of these things could work. So I know that there's a huge amount of focus on that. Keep an eye out in future versions as we add and improve those things and hopefully make it that much more achievable and attainable. Slayer Darth, networking noob, what are some useful primers I can read? I guess it depends on how new to networking you are, right? Are we talking like, I'm just getting familiar with, doing, basic, IP address, subnet, DNS, route configuration things. The RHEL documentation is a great place to start with that. Versus, I want to know how to connect my virtual machines out to the world. Strangely, the RHEL virtualization or RHEL KVM documentation has some really good information inside of there. Remember, OpenShift Virtualization is just an abstraction for RHEL KVM at the end of the day, so all of these things apply. So it does a good job of talking about things like Linux Bridge and connecting these things through it, or OpenStack networking usually goes really in depth on OVS and stuff like that. If we're talking like more OpenShift and Kubernetes things, the nm state documentation is really good. So nm state is basically a YAML abstraction for doing network manager configuration. Network manager is another good one to look into, because network manager is the network configuration subsystem used by RHEL. And then last but not least is the OpenShift virtualization networking documentation. We'll walk through a bunch of things. So I've got somewhere in my backlog, which if I never slept again, I still wouldn't have enough time to get through my backlog. But somewhere in my backlog is a thing to go into, like kind of that whole stack of primitives to help folks understand, like, hey, I'm coming from Red Hat virtualization, or I'm coming from using KVM by Cockpit to instantiate VMs on my individual RHEL nodes or something like that. Like, how do I translate all these things? What are all the things I need to know about learning the OpenShift virtualization stack of technologies? So somewhere in my backlog is getting all those things out there.
Your copious amounts of free time, you'll get it done.
Yeah. Like I said, I just need to never sleep again, and it'll be fine.
No big deal.
All right. I'm sorry, Johnny. I do have to drop. I appreciate everybody joining us today. I'm going to drop. I'll let Johnny close everything out. Please don't hesitate to reach out. At this point, our Hope 9, I know you've got a couple of messages in our inboxes. Johnny's so much better about responding to things than I am. So
that's bad.
Yeah. So anyways, I will see everybody in 2 weeks, I think. I won't be here next week, but Johnny's holding down the fort.
Yep. Awesome job today. Thank you.
Thank you.
All right. Awesome. Yeah. So, Andrew, I know you're not here anymore, but thanks, Andrew, for the presentation. I love how much the technology has evolved. Like I just remember like back in the day doing OpenStack and thinking like, okay, this is really cool, and then seeing OpenShift 4, and then now here we are today, just so far ahead from where we were. If you guys have any questions after the fact, feel free to reach out to us. Slayer Darth, I'm not exactly sure what you mean by network monitoring, so if you want, shoot me an email, johnny@redhat.com, jonny@redhat.com, and we'll with exactly what you're looking for, and we'll try and find some docs for you, or at least get you pointed in the right place with some blogs and things like that. With that said, next week we have Christian again coming on from iSurveillance, and he's going to talk about some of the new things that they're doing. Like we did a stream with him a couple weeks ago on the GitOps channel, and it was pretty cool because he's showing how you can do a bunch of deep level network policy things without having to have like a full-blown service mesh installed. So it was pretty neat. So yeah, he's going to come on and do some more of that. And then I think the week after, it's still open, but we're trying to fill in some of these weeks with some guests to come on and hopefully talk about some cool nerd stuff. So again, if you have any questions, feel free to hit us up, and we'll do our best to answer them. So till next time, if I can find the button here. All right. So till next time, have a good one.